Something that I mentioned in the last videos, as I was looking at those, I recognized that the denominator, the degree of the denominator, was greater than the degree of the numerator, and so that made the u du substitution work really well to fit into natural logs. If the numerator has a degree that's higher than the degree of the denominator, you don't want to just plow ahead with the u du substitution. It's not going to work. So one trick that we can do is using long division for integrating. So check out example number 5. Notice that we have an x squared on the top and bottom. So this is wrong. I'm going to do it in red. If I were to say, oh, I'm going to have u be the denominator, like we've been doing, x squared plus 1, then du is 2x dx, and that does not help me deal with this problem. Okay, I still have an x squared in the problem. You do not want to have to try and solve this for x and plug it in. That's just going to be a big mess. Okay, so if you run into this situation where you have the degree on top and bottom are either the same or the numerator is higher, you want to use long division. So over here we'll do x squared plus x plus 1 divided by, x squared plus 0x plus 1. All right, so we get a 1. That's going to give us x squared plus 0x plus 1. Draw the line and change the signs. That cancels. That gives us an x, and that cancels. Okay, so we have a remainder of x. So we do x over whatever we divided by, x squared plus 1. So using long division, we can rewrite this thing as 1 plus x over x squared plus 1. All right, now you can split this up into two integrals. So we're going to do the antiderivative of 1 dx plus the antiderivative of x squared plus 1 dx. And now you'll notice that my denominator, the degree of the denominator, is greater than the degree of the numerator. So my u substitution is going to work here. Okay. So let's actually get this done. Over on the left side, the antiderivative of 1 is just x. You can just go ahead and do that. Over here on the second one, we're going to let u be x squared plus 1, which makes du 2x dx. So I'm going to have to divide both sides by 2. So I just have x dx. So that gives me 1 over u times du over 2. I'm going to pull that 1/2 out. Still got that x. When I integrate this, I get natural log of u plus c. And then I'm going to plug back in x plus 1/2 natural log of, what was u? Oh, right here. X squared plus 1. Oh, this is a great example. X squared plus 1, that's always going to be positive. So I can ditch the absolute value for just parentheses at this point. And there's my answer. Okay. All right. Number 6. Our directions are integrate using a change of variable. That means a u substitution. That's what we're going to do. We have a couple options here. We could FOIL out the bottom and just do that as u, or we could do the function within a function. I'm going to do it this way because I think it's the way the book does it. They let u equals x plus 1. But if you wanted to FOIL out the bottom and try it a different way, then I'm fine with that. All right, du is just going to be 1 dx. Okay, so we're able to replace this with a u. We're able to replace this, but notice we still have an x in the problem. Let me write down what we have. Right now we have 2x over u squared times du. And we've got x's and u's in the problems, which is not going to help. So what we're going to do is we're going to take this, and we're going to say that u minus 1 equals x, and we'll plug that in. So we get 2 u minus 1 over u squared du. All right. Let's see, what should we do with this? Let's distribute that. So we get 2u minus 2 over u squared. Now, I don't want to do another u substitution because I don't have to. I'm going to split this into two things. This is 2u over u squared minus 2 over u squared. Okay. So that becomes, let's see, one of those u's cancel. So this is going to become 2 over u minus 2 over u squared is just 2u to the negative 2. I can take the antiderivative of that. If you feel very strongly about, you could factor out a 2 at this point, it would be fine. So we have 1 over u minus u to the negative 2. We can take the antiderivative of this. Let's see. So this is going to be natural log of u. And then we need to raise our exponent here, so negative 1, and then we need a negative 1 here. Let's see. So we get 2 times the natural log of, I don't remember what u was, I'm having a terrible time, x plus 1. Those are going to become plus 1 over x plus 1. Plus c. And if you felt very strongly about, distributing the 2 back in, you can certainly find 2 natural log of absolute value of x plus 1 plus 2 over x plus 1. Tomorrow we will do a little bit more with these natural log, and we'll incorporate some trig with it. Very exciting stuff. See you tomorrow.